Alright, so for example 4, we have evaluate the limit as x approaches negative infinity of numerator 12x plus 25 divided by the denominator, the square root of 16x squared plus 100x plus 500. Now again, we're dealing with the square root, so keep that in mind when you're determining your largest power. So for step 1, we would determine the largest power in the denominator, limit as x approaches negative infinity of this function. Now in the denominator, the biggest power on the bottom is x squared, but it's under a square root. So we write that as the square root of x squared like we did in the last example. Now, everyone knows what the square root of x squared is. It's just x, right? But we're going to keep it this way for now so that we can simplify the bottom easier. The top's going to be easy. We can write it as just x because it's more compatible with the top. We don't have to write it under a square root. Okay, so for our next step, we are going to divide the numerator and denominator by this power. So we're going to divide the top by x squared of x squared and the bottom by the square root of x squared. So you can see for the top I can just write that as x. For the bottom I want to leave it that way so I can distribute into this radical. Step 3 is to simplify. So again, the top I'm just going to write that square root of x squared as x. The bottom I'm going to leave it that way. And then I can distribute that square root into that top square root on the bottom and make it one big square root. It's kind of a power law, basically. You can write this all as to the 1/2 or put it all under square root. All right, next step. So now what I'm going to do is and I did notice a slight mistake there. There shouldn't be a 16 there. That should just be x squared. Now what I'm going to do is distribute this x squared into each of these three terms. So it's going to be 16x squared over x squared, 100x over x squared, and 500 over x squared. And now I can basically, the top is going to be easy to simplify. I could have done that first. I'm just going to, I can do, it doesn't matter either one. Okay, so now I can see that these x squareds are going to cancel. This is going to become x on bottom, and this is going to remain x squared. Again, these numbers right here, these constants, they don't affect the limits at infinity or negative infinity because they're finite numbers. What matters is the powers, and that goes back to the rules that we learned for limits at infinity, whether it's x to the n or 1 over x to the n or constant numbers. So these will simplify as I just explained to this. Now let's go ahead and talk about the top since it's so easy. 12x over x is just 12, and then 25 over x is 25 over x. Okay, so it all simplifies to this, and now we can plug in negative infinity to figure out what we get. So for step 4, we're going to evaluate the individual limits. We're going to plug in negative infinity for every time there's an x. And let's see what we get. Okay, so first of all, we have 25 over negative infinity. So we could write that as 1 over x to the first, right? So again, think about if you did 25 over negative a million. It's going to be a really, really, really small number close to 0, so therefore it's just going to approach 0. And again, I can go back and refresh your memory. It boils down to, and we have several rules, so give me 1 second. Boils down to this rule right here, where n is equal to 1, so 1 over x to the first. Well, if I plug in negative infinity, this tells me that the limit's going to be equal to 0. And again, that number on top just simply won't matter, because it's going to be 25 times 1 over x to the first at negative infinity. So it's going to be 25 times 0, which is 0. Okay, so moving along to the bottom, square root of 16 plus, again, this is 100 over a negative infinity is going to approach 0. Same thing for this. The 500 doesn't matter. 500 over negative infinity squared, well, that's still going to be a really big number. It's going to approach 0. I mean, you can get out a calculator, and let's actually get the calculator out and see what that would look like. Okay, so I'm going to take 500. Now, I can't divide by infinity, right? But let's just think of a really big number, like a million or a billion or something. Let's just do something really, well, it won't let me do any more. Okay, so let's go ahead and hit enter. And look, it actually gave me 0. That's funny. It would, the actual answer would be like 0.00000001. Okay, so sometimes it helps to think of these things numerically to see why they turn to 0. And this is for limit, right? This is not actually plugging in. But it makes sense to plug in because you're evaluating the limit, and using those limit rules, we can easily boil these down to just numbers. So now that we have numbers, we can go ahead and go to step 5, which is to evaluate. So 12 plus 0 is 12, and the bottom is the square root of 16. And this is step 5, evaluate the limit. This is going to be 12 over... Okay, now here's the thing. So why am I putting -4 here for square root of 16? Well, remember, the square root of 16 is plus or minus 4. I need to really show this with an arrow so you guys don't get confused, and I want to talk about why the answer is -4. So this goes back to the fact that the biggest power on bottom is actually x, right? Square root of x squared is just x. And you could think of the 16 next to it, so 16x. It's going to take precedent over the smaller powers. It's going to overcome them with the limit because we're approaching negative infinity. So if the biggest power is just x and we're approaching negative infinity, what would that approach? That would approach negative infinity, right? If you plug in negative infinity for x, you get negative infinity. So it approaches a negative number. Because of that, we can make our square root of 16 negative as well to make it -4. 12 divided by -4 is -3. And therefore our limit as x approaches negative infinity is equal to -3. And here is our original question written out. Limit as x approaches negative infinity of 12x plus 25 over the square root of 16x squared plus 100x plus 500 is equal to -3. Here's what the graph looks like. I'm going to put a point on here. As we approach negative infinity, we're going to approach what? We're going to approach -3. The y value will approach -3. It's hard to see that because the asymptote is over top of it. Now check this out. Had it been positive infinity, the biggest power on the bottom would be x, and that would be a positive number, right? So we probably would have ended up with 12, so we would have written square root of 16 as 4 because it would have approached a positive number on the bottom because of that reason. 12 over 4 is 3, and that would have been it if it approached positive infinity. That's it for this example. If you have any other questions about it, let me know.